Continuing the Math 13-14 final exam review with number 22. It asks you to find the equation of the line that's graphed over here. This is a horizontal line, so we know that the equation is going to be y equals a number. And what number is that? In this graph, it's y equals -3. If they asked you to graph, say, find the equation of this line, again, the vertical line there in red, that's a vertical line, so it's going to be an x equals a number, and in this case it would be x equals 5. It's a totally different totally different problem, but I wanted to remind you that a vertical line is x equals a number, and a horizontal line is y equals a number. Number 23, find the equation of the line that is parallel to x equals 6. Okay, so how do you graph x equals 6? It's a vertical line at 6. And it goes through the point 7, 2. So we want the equation of this line. Parallel meaning they never intersect, remember? How do you find the equation of the blue line? It's vertical, so it's going to be x equals a number, and it's going to be x equals 7. Number 24, find the equation of a line perpendicular to the line y equals -5x plus y equals 5 that goes through the point 5, 5. To find the equation of a line, you need two things. You need slope and a point. They give you the point. The point is 5, 5. That's good, right here. But how do you find the slope of the line that you want? Well, they give you another line. Could you find the slope of the line that they give you? Well, if I add 5x to both sides, I get y equals 5x plus 5. So the slope of the line that they give me is 5. I want the equation of a line perpendicular to that line. So if this slope is 5, the slope of the line I want is -1/5. And that's because perpendicular lines have slopes that are negative reciprocals. Okay, point slope form of a line, I reminded you over here, is y minus y1 equals m times x minus x1. So I'm going to use this information to write the equation of my line. I get y minus 5 is equal to -1/5 times x minus 5. Again, I'm using m, x1, and y1. Okay, if I wanted to convert this to a different form, say slope-intercept form, so now I want y equals mx plus b form, I would need to distribute. So I would have y minus 5 equals -1/5 x plus 1. Then I would need to add 5 to both sides and get y equals -1/5 x plus 6. If I want to write it in what's called standard form, ax plus by equals c, I would first want to multiply everything by 5. Actually, I'm just going to do it this way. I'm going to say times 5, and then I'm going to distribute. So I get 5y equals -x plus 30. And then if I add x to both sides, I get x plus 5y is equal to 30. So I have found the equation of a line in point slope form, in y-intercept form, or slope-intercept form, and in standard form. So be careful and make sure you know what form to use according to what form your instructor asks you to give the equation in. Some instructors don't care, some are very specific. Okay, number 25 wants you to graph the piecewise function. If you notice, for x's that are greater than or equal to 1, it wants the line y equals 3. Y equals 3 is a horizontal line, but it only wants it for x's that are bigger than or equal to 1. So from here to the right. So I'm going to erase the rest of it. For the blue piece, it wants y equals negative x minus 1 for x's that are less than 1. How do I graph y equals negative x minus 1? My y-intercept is negative 1. My slope is negative 1, so I'm going to go down 1 and to the right 1. Or I could go up 1 and left 1. So my line looks like this. But I only want it for x's that are less than 1, so I want from here and then to the left. So I do not want anything to the right of 1. I also don't want 1 on blue because there's no equal to. You can also graph this on your calculator. If you go into your y equals, notice that I did the blue was negative x minus 1 right here. Now to restrict the domain, you're going to say divided by x less than 1. For my red graph, I did y equals 3, and I restricted its domains by dividing by x greater than or equal to 1. And the graph in the calculator is exactly the graph that we drew. Some of you may be asking, how do you get these symbols? And you get those symbols by pushing second math, which is actually second test, is above the math key. And that's where you'll find it. I'll go ahead and show you how to enter it. Say the red function, I wanted y equals 3, but I want to restrict that, so say divided by, open your parenthesis, x greater than or equal to negative 1. So I type x, and then I hit second math. Greater than or equal to is number 4. And then x greater than or equal to 1, close your parenthesis. And when you go graph that, it restricts your domain to x's that are greater than 1 or equal to 1. For number 26, it tells you that the parent graph is y equal x squared, and then it gives you f of x equals negative quantity x plus 5 squared, and it wants you to describe the translations. So there are two things going on. The first thing is the negative out front, and that makes it reflect over the x-axis. And the second thing you've done is in here, you've done x plus 5. So that's going to move it or shift it left 5. So if you look at our parent graph here, I've graphed it on the graphing calculator. It's in the dotted line. That's the parent graph, y equals x squared. And then I graphed y equals negative x plus 5 squared, and it's down here. You see that it's reflected over the x-axis, and it's also been shifted left 5. Okay, for number 27, I'm given the parent function f of x equals square root of x. And I am told that the translations I need to do is to reflect it over the x-axis, stretch it vertically by a factor of 3, shift it to the left 2, and shift it down 3. And my job is to come up with a function. So I have f of x equals. If I want to reflect it over the x-axis, I know that I need to type a negative out front. If I want to stretch it vertically by a factor of 3, I know that I need to have a negative 3 out front. Okay, now the shifts. I want to shift it left 2. So under the radical, I want to type in x plus 2. Then I want to shift it down 3. So out to the right, I want to put minus 3. So my blue function here is this function. And it has these properties. Number 28, I'm given this graph of y equals f of x, and I am asked to sketch the graph of y equals negative f of x. So for these 3 points, I'm going to make the y values negative. So I'm going to go do a quick chart here in the middle. And I have -4, -2, 0, -2, and 2, 4. For my new graph, I want to make all the y values negative. So I want 2, 2, and -4. So my first point is going to be -4, 2. -4, 2, right here. My second point is going to be 0, 2. So I have 0, 2 right here. My third point is going to be 2, -4. 2, -4. So getting all of this out of the way, my graph is going to look like this. For number 29, it said to determine whether the equation has a graph that is symmetric with respect to the y-axis, the x-axis, the origin, or none of these. So I'm going to remember that my test says that f of -x, if it's equal to negative f of x, I have an odd function. If it's equal to f of x, I have an even function. And remember that odd functions have symmetry with respect to the origin. Even functions have symmetry with respect to the y-axis. Okay, so here's my function, y equals -5x cubed plus 9x. If I go look at f of -x, I get -5 times -x quantity cubed plus 9 times -x. Four negatives would make it a positive, 5x to the 4th minus 9x. If I factor a negative out, I get, my brain is fried right now. I have -5 x cubed plus 9 times -x. So I end up with 5x cubed, sorry about that, minus 9x. So I'm going to factor a negative out, and I have -5x cubed plus 9x. Why did I do that? Because I wanted negative what I started with. And that gave me this condition. So I have an odd function, so I'm going to have symmetry with respect to the origin. And if I go graph it on my calculator, so what did I graph? I graphed this function on my calculator and got this. You can see that there's symmetry with respect to the origin. For number 30, you're given f of x equals x to the 4th minus 4x squared plus 1. Again, I want to plug in f of -x. So I have -x to the 4th minus 4 times -x squared plus 1. I get x to the 4th minus 4x squared plus 1, which is f of x. Since f of -x was equal to f of x, I have an even function, so I know that I have symmetry with respect to the y-axis. If I graph this function on my calculator, I can see that I have symmetry with respect to the y-axis over here. For number 31, I'm going to do the same thing. F of -x. Evaluate the function at -x. I get -3 x cubed plus 9 times -x squared minus 3. So I get 3x cubed plus 9x squared minus 3. That is not equal to f of x. It is also not equal to f of -x. So I have a case that this function is neither even nor odd, and there's going to be no symmetry with respect to the origin or the y-axis. If I look at the function graphed on my calculator over here, I do not have origin symmetry, nor do I have y-axis symmetry. For number 32, I was given this graph and asked to describe the transformations and give an equation for this graph. First thing I notice is that the parent graph is y equals square root of x. I see that I have been shifted to the left 7 units. So I want to move left 7, and then I want to go up 5. No, what is that? 6. So my graph is going to be the function f of x equals square root of x plus 7, that moves it left 7, and then plus 6 out to the right moves it up 6. Number 33 tells me to sketch a graph of this function and list all transformations from the basic function. And the function is y equals 1/3 x plus 5 quantity cubed plus 4. So the parent graph is going to be y equals x cubed. And actually I'll write that in red because over on the calculator I graphed it in red. You'll see here. I have a vertical compression by a factor of 1/3, and that's right here. And then I want to shift it left 5, and I want to shift it up 4. When I graph that on my calculator, I get here, and you'll notice that the original point 0, 0 was moved left 5 and up 4 right here.